All right, I'm now recording. So we're going to do the bottom half of page 7. I do have a video that we will watch together to help us. Let me go to share screen here. The reason why I like this video is that he goes into a lot of detail about how we do reverse operations. I mean, order of operations in reverse order or backwards as we solve equations, and he explains it very clearly. So I want to make sure, can you see this screen? Because when I did Kahoot yesterday, when I put it on the big screen, we couldn't see it anymore. Okay. Something else popped in. All right. So we're going to watch the video. Let me shrink this. Okay.
Hi, I'm Ron. Welcome to Math Antics. In the last 2 algebra videos, we learned how to solve simple equations that had only one arithmetic operation in them. But often, equations have many different operations, which makes solving them a little more complicated. In this video, we're going to learn how to solve equations that have just 2 math operations in them, one addition or subtraction, and one multiplication or division. And the concepts you learn in this video will help you solve even more complicated equations in the future. Now, as you might expect, equations that have 2 arithmetic operations in them are going to require 2 different steps to solve them.
And that's what we're going to be getting into today and next week. Okay, so instead of just adding or subtracting, we're going to have to do 2 things.
In other words, to get the unknown all by itself, you'll need to undo 2 operations. But that doesn't sound too hard, right? I mean, we learned how to undo any arithmetic operation in the last 3 videos. And that's true. But there's a couple reasons that make 2-step equations a little trickier to solve. The first is that there's a lot more possible combinations of those 2 operations. And the second is that when there's more than one operation, you have to decide what order to undo those operations in. Hello? If you need to know what order to do operations in, just follow the order of operations rules. You did watch that video, didn't you? I sure did. But the order of operations rules tells us what order to do operations, not what order to undo them. Oh, well, then could we reverse the order since we're undoing the operations? Now that's a good idea. Well, of course it is. When solving multi-step equations, that's basically what we're going to do. Using the order of operations rules in reverse can help us know what order to undo operations in. But it can be a little tricky actually putting it into practice. So, to see how it works, let's start by solving a very simple 2-step equation. 2x plus 2 equals 8. In this equation...
So which one are we going to do first? Are we going to remove the times to get x by itself, or are we going to start with getting rid of this plus 2?
Times first?
So when we follow order of operations, correct, let me have it up here somewhere. Yeah, when we follow order of operations, we would start with the times. So what he is saying is when we are solving for x, we have to do it backwards. So you can look at your chart here, and at the bottom it says addition or subtraction. So we're undoing it. We're we're taking the problem apart. Does that make sense?
Yeah.
Yeah, so that's confusing. So when we're doing on our paper here, where's this one? On this side, we are doing order of operations backwards. Okay. And when we do it on this side, when we're checking our work, we do it regular. So that is something tricky that we're going to have to get used to. Let's get a text box to write it. So on this side, let's see, addition, subtraction. So addition, subtraction, multiplication, division, exponents, and parentheses groups. Okay, So notice how it's backwards this way. And then when we do it on this side, let me get rid of that arrow. That was a very thick arrow. Scoot this over a little bit. Oops, not that one. Okay. Move this back. Oops. Okay. And then when we're checking our work, we do groups, exponents, multiplication, division, addition, subtraction. So can you see how this way, when we undo it, when we solve for x, we're doing it backwards? Let's see. Can you guys see this right here? Does that make sense, or is it pretty confusing? Yeah. Yeah. So we can, so that's the part that I think is the tricky part of this, the part that makes it confusing. Okay, but watching this video, he's going to go through how we're doing this backwards. So back to our video.
The unknown value, x, is involved in two different operations, addition and multiplication, which is implied between the first two and the x. And to undo those two operations, we need to use their inverse operations, subtraction and division. But the question is, which one should we do first? Like many things in life, the order we decide to do things in can make a big difference. Come on, there's gotta be an easier way. First socks and shoes. Fortunately, in math, we have a special set of rules that tell us what order to do operations in. Those rules tell us to do operations inside parentheses or other groups first. And then we do exponents. And then we do multiplication and division. And last of all, we do addition and subtraction. Those are the rules you need to follow when simplifying mathematical expressions or equations. But solving an equation is different because we're trying to undo any operations that the unknown value is involved with, so that the unknown value will be all by itself. So when solving equations, the best strategy is to apply those order of operations rules in reverse. Using the reverse order of operations is not the only way to solve a multi-step equation, but it's usually the easiest way. Just like it's much easier to take your shoes and socks off in the reverse order that you put them on.
So do you guys get that example? I'm sorry if it's lagging. I'm going to post this video also separately so you can review it again if you want. So did you notice when he was trying to put his sock over his shoe? He did that, what, 10 seconds ago or something? This picture right here?
His shoe's too big.
Yeah. So do you put when we put our shoes on, we put our socks on and then our shoes. But when we take our shoes off, we have to take off our shoe before we can take off our sock, correct?
Yes.
Yeah, it's a process, okay? So that was the example he used, and I think that does help it make more sense of why we have to do it backwards, right? We don't put on our shoes and then our socks. And when we take off our shoes and socks, there's no way you could take off your sock before you take off your shoe. And just the same way with this, when we're unpacking X or trying to get X by itself, we have to do it backwards.
Are you sure it's socks before shoes? Since the order of operations rules tell us to do multiplication before we do addition, we should undo addition before we undo multiplication. So first, we undo the addition by subtracting 2 from both sides of the equation. On the first side, the plus 2 and the minus 2 cancel each other out, leaving just 2x on that side. And on the other side, we have 8 minus 2, which is 6. Next, we can undo the multiplication by dividing both sides of the equation by 2. On the first side, the 2's cancel, leaving x all by itself. And on the other side, we have 6 divided by 2, which is just 3. There, we've solved the equation using the order of operations rules in reverse. And now we know that x equals 3. That wasn't so bad, was it? Let's try solving another simple two-step equation that has division and subtraction in it. X over 2 minus 1 equals 4.
Oops.
Again,
Okay, so what are we going to do first? Are we going to get rid of the division or get rid of the minus?
Minus?
Yes, the minus, because we have to follow order of operations backwards because we are undoing it. Nice.
we're going to apply the order of operations rules in reverse to undo the subtraction and the division operations. Since we would normally do the subtraction last, we're going to undo it first. To undo the subtraction, we add 1 to both sides of the equation. On the first side, the minus 1 and the plus 1 cancel out, leaving just x over 2 on that side. And on the other side, we have 4 plus 1, which is 5. And then, to undo the divided by 2, we need to multiply both sides by 2. On the first side, the 2's cancel, leaving x all by itself. And on the other side, we have 2 times 5, which is 10. So our answer is x equals 10. Those examples are pretty easy, right? But solving two-step equations gets a bit trickier thanks to...
Okay, so we don't have to watch the whole video. We watched about 5 minutes. I think that is what we need to know for today. So I need to know, how are we feeling about this? We're feeling thumbs up, thumbs down, super confused, middle. Middle, okay, middle is good. All right. Middle, okay, that's good to know. I've seen a lot of middles, all right. So we are now going to get to our page, not that one, this one. Okay. So we did yesterday problems 1, 2, and 3. So we're on page 4. I'll show page number 3. I mean, we're on page 7. I said that wrong. Problem number 3 for review. As you can see, that's what we did yesterday. It said x minus 7. So we added 7 to both sides. We had to do the opposite operation. I'm still drawing arrows for us to remind us that we write what we do. Okay, we don't write what the problem says. We write what we did. And we added. So we did APOE. We got our answer. Then we take our answer. We come over here and we substitute. So if x is equal to 19, we switch 19 out for x and we solve. And we want to know if the numbers match. If it checks out, we did it correctly. Okay, so this is still one step for number 4. Number 5, we will do 2 steps. So in number 4, it says 21 equals -3 plus x. So if this is -3 or -3, what do I need to do to get x by itself? Oops. What do I need to do to this 3?
You have to plus it with the x.
Yeah, or I'm not plussing it with the x, but I do have to add it on both sides. So we're gonna do +3, because what I do to one side of the equation, I need to do with the other, right? We have to keep our equation balanced at all times. So we got +3 plus 3. Yes, +3, good. So -3 plus 3 equals 0, right? I know that. because if we go here and we add 3, 1, 2, 3, we are at 0. They cancel out. And we call that the 0 term because it makes 0. Why is that one? Now we can add 21 plus 3.
24.
Yes, 24. Okay, so 24 equals x. Now I want to look at what I did, right? So what did I do to this problem?
Add
Add. So what do I write over in the given?
APOE.
Correct. And does anyone remember what APOE stands for? A is addition. What's POE stand for? Property of
Equality.
good, equality. Meaning we are doing it to both sides of the equation. So I take my 24, plug it in over here. I have to remember to write my 24 again up here because there's a space for it. And it's saying if is 24, is x equals 24 a solution to the equation? So now that I have that, what am I doing? I have this information. What am I doing to it with it?
Check it if it's right.
Yeah, so I have to rewrite the problem with the answer I got because I got 24. So I need to know, was that right? Okay. So on this side, we only have one step right now, but we did addition and subtraction, and we always want to start with that when we're solving for x. But then when we check our work, we want to follow the regular order of operations like we're used to. Okay. So I have, oops, -3 plus 24, what is that? So if I have my number line, I start at -3, that's my start. My change is positive 24. I'm adding 24. So I'm moving to the right. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 21. Yes, thank you, Jolene. We'll go all the way, and I know this stops at 20, but we just needed to go one more. So our number line was still helpful for that problem. So 21. Remember that after I complete a step, I rewrite the entire problem again in the same order with my simplified answer. Okay. So is 21 equal to 21?
Yes. Yeah.
Yes, I put my check mark, it checks out. So yes, 24 is a solution. Okay. Next one. Using a different method, we're going to skip that part. Okay, so when we have a fraction, so that could be intimidating because now I have a fraction with an x, but teacher, you're telling me to do it backwards, and when I look on here, they're equal. And some people, they reverse the reciprocal. So if you are able to do that, you can, but I like to break it down one step at a time. So I'm going to show you how we do that, okay? So when I have a fraction and I'm trying to get x by itself, I always start with the denominator, okay? I'm going to get rid of that bottom number. And what's the opposite of division?
Multiplication.
Yes, multiplication is the inverse operation. So I'm going to multiply both sides by 3 because 3 is the bottom number. Okay, check. And then 3 over here. Okay, now that I have done that, these 3's cancel out, right? It's the big 1 factor we're talking about because 3 divided by 3 is 1.
Yes.
Okay, and 1 times 5 is 5. Okay, so that's why it's invisible. So you guys know I love crossing things off. I'm going to put a big old line through there. I do not need it. Now I'm going to rewrite my problem. Okay. Clean this up. And as I rewrite it, I'm going to simplify this answer also. Okay. So what I'm looking at now is I see 5x equals, and then 10 times 3 is
13.
30.
My bad.
Yeah, I'm hearing similar things. Okay, we're all in agreement. 10 times 3 is 30.
Yeah.
Okay, and a negative times positive is?
Negative.
Okay, so I'm looking at negative 30 over here. See how I'm lining this up? When you write it on your paper, it might be easier for you to do that than me on this computer. So now I have 5x, and 5x means 5 times x equals negative 30. Okay, so now do I have a fraction? Or is the fraction gone? Let me scoot that down a bit. So when I'm looking at 5x equals negative 30, is there a fraction or is has the fraction been eliminated? Ethan, is the fraction here or is it all gone?
The fraction is there.
It's still there?
No,
Where?
No.
No, it's not. Okay. Yeah. I
The
remember.
fraction is all gone.
Yeah, and we can always mask things, right? So if that's confusing, we can cover it. And when I'm looking, is that easier to see that the fraction is gone?
No. Yes.
Yes. Okay. So cover that part up. Don't even have to look at it. Okay, getting back to my problem. So now, actually, I don't want that right now. So now it says 5 times x, right? And the opposite of times is the inverse operation for multiplication is
Division.
division. Okay. So I'm going to erase my box I made. Okay, so first we had a times to get rid of that, and now we have to divide to get rid of the 5. So I'm going to divide both sides by 5. Okay. And we're always dividing by the number that is attached to the x. The other day I was saying that it's like 5 is married to x and married is multiply. They both start with an M, and now they're getting a divorce, right? Divorce and divide both start with a D. Okay. So what number cancels out? What can I cross off?
The 5s.
Yeah. Yeah. You can cut up the 5s.
All right, I'm gonna cross these off, they cancel out. So is x by itself now?
Yes.
Yes, finally. So yeah. And then I see 30 divided by 5, what's that? Negative 30 divided by 5?
30, negative 30 divided by 10
5?
is
6.
6, good. So 5, we go to 30, 6, and then a negative and positive is?
Negative.
Yes,
Negative.
still negative. Cool.
is
Okay, so I've simplified it as far as it can go. I'm down to one number. If you notice, everything is, I'm trying to line it all up. All my equal signs are right under each other, right? This helps keep us organized and it helps us understand the problem when we're looking at it. Okay? I really have to stress that because some people do not do that and they write everywhere. Or they write the numbers, instead of answering them down, they write them side by side and it gets confusing. So -6. And we did 2 steps. So we need to write both steps we did. So see up here in that blue writing, what did we do first?
Multiply.
Yeah, so what are we writing for our reasons? Given
Property of equality.
yeah, good. So MPOE? Yes, multiplication, property of equality. Nice remembering, Jolene. Okay, and then the next one, what's the other step we did?
is divide.
Yeah, so we write input POE first, and then we write DPOE second. Because we completed 2 steps. We'll write our answer, -6 over here again. Okay. And I want you guys to work this problem out and let me know if the answers match or not. Okay, so I'm looking at 5 times 6, or 5/3 times 6 equals -10. So I have a fraction times a whole number. Oh, -6. Why do I forget to put that in there? Excuse me. Didn't fix that. There we go. 5 times -6, or 5/3 times -6, I mean to say, okay. So what do I do when I have a fraction times a whole number?
Line and a 1.
Yes, line and a 1, thank you. Got my line and a 1, all right. Does 5 go into 3?
No.
No.
I don't know. Good. Does 6 go into 3? Do they share any factors?
Yes.
Yeah.
Yeah.
Which one?
2
2 times what?
3.
times 3.
Okay.
Yeah, I will 2 times 3.
Okay. And there's a negative in there too, so I'm going to put -2 times 3 because I don't want to forget my negative. Okay. There we go. And I'm crossing off my 6 and negative because I just wrote it another way. Now I can cross off my 3's, correct?
Yes.
Yes.
Yes, crossing off my 3's. Okay, let me rewrite this. And now I have no more denominators. I only have the 1. So do I still need that?
No.
No, I don't need it anymore. I can cross it off if I want to remind me when I'm rewriting it. Okay. I only use the 1 as a visual to help me factor this out. Okay. Oops, not pink. So I have 5 times -2 equals -10. Okay. So I cleaned up this problem for us. When I'm looking at this, I have 5 times -2 equals 10. So what do I do next?
You multiply.
You put a line in a 1.
Okay, I'm hearing I multiply and then I hear a line and a 1. Do I have a fraction, Ethan?
Oh no. No, you multiply.
Multiply, okay. And 5 times 2 is?
-10.
Yeah, 5 times -2 is -10. So I write the new answer directly beneath the top one. I bring down my equal sign and I bring down the rest of the problem. So is -10 equal to -10?
Yes.
Good. I love it when it matches. It means I don't have to go back and find the error. Cool. Got my check mark on there. Going on to the next problem. Just kidding. We're skipping this one. We don't have to worry about this, okay? So the second part of number 5, talking about a different method. We will not stress out about that today. We have other things we need to cover. Okay, so just cross that one off. Because I want us to continue practicing these kinds of things. Okay, so you guys can do 6, 7. 8 has 2 steps, 9 more steps. Okay. Okay, we might be able to get to page 8. Cool. Okay, and if I forgot to mention it, or if we forgot, when we have our evaluation or our test, it's going to be a problem just like this, where we have to solve it, and we have to write our reasons, APOE, SPOE, MPOE, DPOE, and then we have to be able to check our work. Okay, that's going back to our learning targets. The one we are not doing yet is finding and fixing the errors, but we will. So for number 6, what am I going to do?
We're skipping number 5.
The bottom part, yeah, see, is there a big X there? So don't even worry about that. Okay. So I'm on problem number 6. And it says x minus 8 equals negative 16. So what am I going to do?
Plus.
Plus, yes. So am I going to add 8 or am I adding 16?
Add 8.
Yes, because why? Can you tell me why?
Because it has to be equal.
Okay, that's why we add 8 on both sides, but we're adding the 8 because that is the side that has the variable on it.
Yeah.
Yeah, so we always want to do the inverse operation on the same side of the equation that has the variable. Okay, that's how we get the variable by itself, and the goal is to isolate the variable. Cool. So yes, I feel like we're catching on to that, but I'm not sure if we understand why. So now when I do that, negative 8 plus 8 is 0, so it cancels out. Okay. So now I have x equals, and we have, let's practice rewriting our problem here. What is negative 16 plus 8?
Negative 8.
Nice. Yes, that is correct. Okay. Negative 8. Okay, so what I'm trying to do is I'm trying to line up the equal sign. So the equal sign is here, x is by itself, and then negative 16 plus 8 is negative 8. Very nice. And what do I write for my given, my reasons?
Add property of equality.
Yes, POE, because I added. Good. I was seeing if we could do that without the arrow there, and we did. Awesome. Take my negative 8. Plug it in here. And it says, is negative 8 a solution to the equation? Oh, look, they have a typo. They just wrote negative 8. Anyone else catch that?
Yeah.
I didn't do that. All right. So we're going to rewrite the correct equation, not the messed up one. Okay, so we're going to write negative 8 minus 8 equals negative 16. And we simplify. What is negative 8 minus 8?
Negative 8 minus negative 8 is 1.
Is it? Let's see.
No, I'm on negative 7.
So I have negative 8 over here, and I'm minusing 8. So am I going to the right or to the left?
To the left.
Okay, 8 times. That's a change. So 1, 2, 3, 4, 5, 6, 7, 8.
Negative 16.
Yes. So thank you. And let's make sure that we have our number line. So I want to make sure that we are using them, because it's easy to do that when we do it fast in our heads. You guys see me. I make mistakes all the time. That's why I really stress using number lines. So I thought it was 0 or 7, but I double checked on the number line and said, oh, wait, it's negative 16. I'm glad I used my number line. Okay. Right. And is negative 16 equal to negative 16?
Yeah. Yes.
Okay. Cool. Why is that being super thick? I don't know. All right. How about the next one? 5 times x equals 12. What do I need to do?
Divide.
Yes, because it says multiply. I want to do the opposite. I want to divide. And am I dividing by 5 or 12?
5.
Nice. All right, these two 5s cancel out, making the great big 1 factor. So I have x by itself. Can we divide 12 by 5? No. Good.
No. No.
And we can't simplify it either because they don't share any common factors. So are we just going to leave it like a fraction? I mean, what do we do if we can't simplify it? Yes, we do leave it because it is simplified. That's as small as it gets. Good. Or you can convert it to a mixed number, but that's not our learning target, so I'm not worried about that. All right, yes, good. All right, good. Thank you, Ethan. We're all on the same page. And then what do I write for my reasons?
DPOE.
Yes, DPOE, because we divided. How are we feeling with writing our reasons? Because I know that's something that's very brand new to us. Are we feeling more comfortable or more confident with that?
Yeah.
Yeah, good. Yeah, I hear a couple of us sound confident about it, and then I just wanted to check in. If not, you could always message me privately, or we can work on it at a different time, not during the 10 o'clock hour, but we can schedule a different time. And I have a couple other resources that can help us with some of this stuff. Okay, so I have 12 over 5, plugging that in over here. Okay. Let's see, we got 12 over 5. I'm rewriting my problem. So I have 12 times, no, 5x. 5 times 12 equals 12, and then 5 over here. And right there. Actually, I can do Let's let me move it. It's freezing. Oops. Yeah, it's lagging for me too. Sorry. It's not unfreezing. All right. So yours should say there's a fraction line here. Mine's over there. Oh, there we go. Okay, so there's a 12 on top. I also see a 5 on top and the 5 on bottom. So is there something I can do? It's frozen. Am I frozen too, or just the screen? Because my screen's frozen on my end. I'm using the school laptop, so it's a little older than my regular one.
It's just me.
Okay, yeah, it's
Just a screen.
being completely frozen. I can't even scroll it up or down. The last time I think I had to close it and redo it. Let's see if that'll work. Okay. Let me go back in classwork. That's page 7. See, it's still lagging. Apologies. Well, while that's doing that, since we were having a little bit of practice, whole numbers, this IXL is something that we can practice also, which is good practice for what we're doing today. Let's see, is this up here? No, that's the wrong one. I want that one. Okay, let's see if that helped. There, yay, it's working now. Okay. So I have a 5 on top and a 5 on bottom. Do I need a line and a 1, or can I just cross them off like I do when I have the X?
Cross it off.
Yeah, let's just cross that off. Crossing that off there. Okay, so now I'm going to rewrite my problem.
Ooh. Oh.
12 equals 12. All right, am I done?
Yes.
All right, am I putting a check mark or no check mark?
Yes.
Check mark.
Cool. Check. Okay, now that we have another fraction with a variable, okay? So we have to do 2 steps for this one, right? So if you are comfortable with reversing the reciprocal and you know what that is, you can go ahead and do it. I'm not going to do that here on this video. But can someone tell me, what do I do? What am I doing first? With my fraction, I have a numerator and a denominator. So which number do I want to start with? We have a 50-50 chance of getting it right. We only have 2 options here. We're going to start with the top number or the bottom number. 4. Yeah. Okay, so someone said 4, someone said top. Okay. So yes, I want to start with the 4. I always want to start with the bottom number. The reason why is because, can you divide 3 by 4?
No.
No. So that's just making the problem more complicated for us. But we can times it, right? We can times them. So I'm going to, and the variable's on the right side now, but does that matter? Does it matter if X is on the right side of the equation instead of the left?
No, it doesn't matter.
Doesn't matter, right? That might throw some people off. So I'm going to multiply both sides by 4. I guess I'll put it like this because there's a, no, there's 2. And after I times it, I just cross these 4s off. They're canceled out. Boom, they're gone. I do need to times 4 times 15 though. So I have my times chart. And what is 4 times 15?
60.
60. And I have a
60.
negative and a positive. So negative and a, I'm sorry?
Negative 60.
Yes, negative 60. Very nice. So I'm rewriting my problem. Let me help clean this up. I know it can get confusing for some of us, right? So I have negative 60 equals, and then after I crossed off those 4s, I only have 3 and x. Okay, I'm going to try and line this up for us. Okay. So I rewrote the problem. Okay. Now I have the top number. Okay. Now I have my numerator only. So I have 3 times x. So what am I going to be doing? The inverse operation. So the opposite of times is
Divide.
divide. They're gonna 3 is gonna get a divorce from x. Good. Oops. What number am I crossing off? Anything cancels out?
The 3s.
3's cancel out. So x will be by itself. I can see that happening. And then I need to divide 60 by 3. Let's see if that's on our chart or not. Let's see. So does it fit on our chart? What is 60 divided by 3?
$20.
20. All right. Oh, and I have a negative. So is it going to be positive 20 or negative 20?
Negative 20.
All right. So rewriting this for people who want to see it cleaned up first. Negative 20 equals x. Okay. Everything's nicely lined up. So put my answer over here. Negative 20. And then what am I writing for my reasons? Right. I got to write what
Divide.
first. Okay, I did divide, but did I do something before I divided?
SPOE.
There's a negative sign, but did we subtract?
Multiply. MPOE.
MPOE, yep, and then we write DPOE. So yeah, we have to follow. Some people, they like to do the step, like if they multiply it, then they'll write the reason right after. We'll try that on the next problem that's like that, because that does help some of us. So I want to make sure that we're showing a couple different strategies here for that. All right, so we're writing MPOE and DPOE. Got my negative 20. Make sure I plug that in. gotta rewrite my problem with the value, with the answer I got. So negative 15 equals 3 times negative 20. Enter. Put 4 down there. Okay. Move this up a bit. Put in a fraction line. Okay, so what do I need to do? I have a fraction times a whole number. What do I need to do?
Line in a 1.
Okay. Yeah, and we're doing that because, well, it's not a 4. It's not something that cancels out easily. So I want to break it down a little more so it's easier for me to solve. And I know 3 doesn't go into 4. We were just talking about that. But what about 4? Does 4 go into 20?
Yeah.
How many times?
5 times.
5 times.
Time.
Right. If you notice when I'm rewriting the factors and there's a minus, I never put the negative sign with the number I want to cancel out. So I'm going to put 4 times negative 5 because I want to make sure that I'm keeping my negative in there. Otherwise it will change my answer. Okay, so I'm crossing out my negative 20 because I wrote it a different way. I can now cross off my 4s. Okay. All right, so let's clean this up. Rewriting my problem with my new simplified answer. So I have negative 15 equals, I'm looking at 3 times negative 5. Okay. So this top one and the bottom one says the same thing. This bottom one is easier to read. So what is 3 times negative 5?
Negative 15.
Negative 15. That is correct. All right, so do my answers match?
Yes.
Nice. Gonna put a little green check mark there. Yay, they match. All right, so there is 2 more problems on there. All right, so I'm not gonna go over these today. I would like you to try problems 9 and 10 on your own. And before I move on to that, I want to remind us about the IXL. Not that one. Okay. And these IXLs, when you complete them, you get points for them and they count for your 15 minutes. Okay. So Z.6, solve one-step equations with whole numbers. That's what we're doing here. So this is some extra practice. There's a link for it, and I'll put the link for this one again in the page 7 to turn in. That way there's another way for you to find it. It's starred. I have it in PowerPoint presentations, the Google Slides that I made. There is a link for it under IXL. Oh, it's gone. Let me go to, not there. Let me create a new one for classrooms.
Miss Johnson.
Yes.
So if we like the one that is due Friday or today, if we finish early, didn't you say we could get off if we get like 85?
Yeah, so with these assignments that I'm giving us to do, here's the Z6 one I was trying to show you. I have a link for it. So if you get your score of 85 and you finish in 7 minutes or 5 minutes or 10 minutes, it's okay. It's going to count for your 15 minutes.
Okay.
Okay, as long as you made your SMART score, right? I want us to have like an incentive, a reason, like, yeah, let's do it. Let's get it done faster, you know? So it's kind of a built-in reward, if you will. So that's good. So yeah, I have a link here for you. I can put it in page 7 again, or, so another way to find it. And it's also starred in iExcel. So I wanted to do a couple example problems again, just to make sure that we're getting this. So this says y divided by 8 equals 9. So if this is divided by 8, what do we need to do?
Times.
Times by 8. Okay. And you can write it out on a piece of paper next to you if you need to. Okay. And then 9 times 8 is 72. Okay. Oops, I'm not signed in. Oh, it didn't tell me. Okay, we're going to do it again. So if you get it right, so this says 6 times W. So we want to divide by 6. What's 72 divided by 6? Let's see, we go to 6. We got 72 and it's 12. So it's 12. Enter. Well done. And then if you forgot how to do it or you don't know, isn't there a way to do it? So let's say we did this wrong and I didn't minus it. Let's just say I put 100 for my answer. Incorrect. It'll show you the steps. Okay. So it'll show you and remind you how to do it. So if this says plus 64, we want to minus 64. So 9 minus 4 is 5. 9 minus 6 is 3. So is it 35? Did I do that right? Let's find out. Woohoo! But this is a good way to practice doing the order of operations backwards, or not that part. I meant doing the inverse operation. Okay. So this is, if this is addition, we're going to do SPOE and we're going to subtract. And that way we could focus on doing it with one step. Okay, so that's all I have. That's all we're doing for today. Are there any other questions? I'm sorry it's lagging a little bit. It's probably the internet. Let me stop share on that. Okay. An alarm's going off by my house. Are there any other questions?
No.
No.
Okay, so I'll see you guys later.
All right. Yes.
Miss
All right.
Johnson. Miss Johnson, can I get the code? I didn't get the code in order if I want to see
Okay.
the
bye.
classroom code.
Bye.
Classroom.
Need the, let me stop recording.